Okay, hi everyone. Today we want to talk about the HELYATI. So HELYATI is chemically known as 2-bromo-2-chloro-1,1-trifluoroethane. It is a volatile liquid anesthetic that has been widely used in clinical settings for inducing and maintaining general anesthesia. It was introduced in the 1950s as a safer alternative to earlier anesthetics like ether or chloroform. So next, the structural formula for HELYATI is C2H-BrCl-F3. So next, we move to the functional group of HELYATI. So HELYATI contains single carbon-carbon bond. That name is ethane backbone. Next, HELYATI contains 3 fluorine, 1 bromine, and 1 chlorine, which is halogen group that attach to the carbon atoms, making it a halogenated compound.
Okay, next, nomenclature. IUPAC name for HELYATI is 2-bromo-2-chloro-1,1,1-trifluoroethane. First, HELYATI need to break down. Parent structure is ethane, a 2-carbon alkane group, C2H6. Second is substituents. 2-bromo indicates a bromine atom that attaches to the second carbon atom. 2-chloro indicates a chlorine atom that attaches to the second carbon atom. 1,1,1-trifluoro indicates 3 fluorine atoms that attach to the first carbon atom. Numbering starts from the carbon atom that ensure the lowest number possible for the substituent, for example. Next is properties. We know all the chemical have 2 properties, which is physical properties and chemical properties. For the physical properties, HELYATI is a clear, colorless liquid that has a slightly sweet and non-irritating smell. HELYATI has a melting point of approximately -118 degrees Celsius and boiling point of 50.2 degrees Celsius. HELYATI are slightly soluble in water and fully soluble in organic solvent such as ethanol, ether, and chloroform because HELYATI is a non-polar compound. So next is chemical properties. HELYATI is stable under normal conditions but can decompose when exposed to the light, heat, or a certain metals such as aluminium and iron. HELYATI are non-flammable and non-explosive. HELYATI can react with oxygen over time, forming acidic and corrosive byproducts.
Synthesis of HELYATI. First, reacting 3-chloroethane with a hydrogen fluoride in a presence of antimony trichloride to produce 2-chloro-1,1,1-trifluoroethane. This is then further reacted with a bromine at a high temperature around 450 degrees Celsius to form HELYATI, 2-bromo-2-chloride-1,1,1-trifluoroethane.
Okay, now I'm going to tell you guys about key step in the synthesis of HELYATI. The first step is addition of hydrogen fluoride to 3-chloroethylene catalyzed by antimony trichloride at high temperature around 130 degrees Celsius to produce 2-chloro-1,1,1-trifluoroethane. The second step is bromination of 2-chloro-1,1,1-trifluoroethane at high temperature around 450 degrees Celsius to form HELYATI. As you guys can see, this is a 2-chloro-1,1,1-trifluoroethane structure. Heating 2-chloro-1,1,1-trifluoroethane with bromine at 450 degrees Celsius replaces a hydrogen atom with bromine, forming HELYATI. And the practical application for HELYATI is used in the medical industry as an inhalational anesthetic for general anesthesia during surgery. HELYATI is an inhalation anesthetic that used to induce and maintain general anesthesia in operating room. HELYATI also is one of the most common inhalation anesthetic used today. And last but not least, HELYATI can alter the permeability of blood-brain barrier which can increase the intracranial pressure, or as known as ICP.
To conclude this presentation, HELYATI was an important compound that helped people to sleep through surgeries without pain. It can turn into gas easily, which make it a good option during surgeries. It is also not flammable, which make it safer to use in hospital. HELYATI is stable under normal condition. However, under some case, it can break down into harmful chemicals for human. Because of this, doctor has now used a safer anesthetic instead. However, it is still used in animal practice because it works well. HELYATI reminds us that science keeps improving. It was once a big discovery, but better and safer option has now replaced it. Even though it's used less today, it has helped medicine to grow significantly. Thank you from us.